Satellite projects by Indian students. Abstract, Indian Space Research Organisation, ISRO, has launched more than 100 satellites for various applications like communication, Earth observation, astronomy, navigation, lunar studies, and interplanetary mission from its inception. Addition to its own programs, it induced Indian student community to make satellites by guiding, providing facilities to test the subsystems and satellites. It also launches these satellites by Polar Satellite Launch Vehicle, PSLV. The student satellite projects provide the design, fabrication, assembly, and testing experience of electrical and mechanical systems to university students. It provides experience in project management, budget, schedule, and mission planning and operation also. Indian students have launched more than 9 satellites so far and some more are under development. Due to this inspiration, many universities/colleges had flown their satellites through balloons for testing their capabilities. Some students launched their satellites through other space agencies also. This paper presents the salient features of these satellites and technologies used in Indian student satellites. Keywords: student satellites, nano-satellites, university satellites, miniaturization. Introduction. The artificial satellite is a system which mainly goes around the Earth with a specific purpose. It is a multidisciplinary system which can be divided into 2 main parts based on their functions as payloads and mainframe. Payloads are the instruments or sensors which are directly related to the applications. In the case of remote sensing satellites, they are cameras/imaging systems, synthetic aperture radars, SAR, scatterometer etc. And in communication satellites they are receivers and transmitters. Some scientific purpose satellites carry instruments to measure the electron contents, gamma ray detectors, X-ray monitors, ultraviolet detectors etc. The mainframe, sometimes called as bus, which carries the payload. It can be broadly divided into electrical and mechanical systems. Electrical subsystems are power system, communication system, data handling digital systems, and attitude and orbit control system. The power system generates power from solar radiation in sunlight, stores it in battery for the requirement of eclipse duration operation, and distribute the power among different systems. The communication system is to receive the command from the ground stations and transmit various information like temperature, pressure, power consumption of different systems, and attitude and orbit information of the satellites to the ground station. Addition to this, it transmits the high-volume data collected by payload instruments to the ground. The data handling digital system collects the telemetry information from different systems, format them and transmit to communication system 1. It also collects the commands from communication systems and distribute to relevant system. Addition to this, the data handling system collect data from payload instruments, compress, encode and send to communication system. The attitude and orbit control system consists of various sensors and actuators. It measures the attitude and orbit information from sensors and activates the actuators for correction if required. The spacecraft mechanical systems are structure, thermal control systems, TCS, and mechanisms. The structural system is the skeleton of the satellite, mainly made up of aluminum alloys and carbon fiber reinforced plastic, CFRP, materials. It provides space to mount the electrical and other mechanical systems. The structure is designed to provide sufficient stiffness to maintain the look angles of the payloads and attitude sensors. The thermal control system provides suitable thermal environment to the electrical and other mechanical systems for their better functionality. As size of some systems like solar panels and antennas violate the heat shield volume of the launch vehicle. They are to be kept folded during launch and deployed after reaching orbit. For this purpose, some mechanisms are designed and employed. Orbit raising and attitude correction are done by propulsion system. Many satellites are using chemical propulsion for its high thrust and simple design. The combination of these mechanical and electrical systems is called as mainframe and to support payloads. Each system has interface with other system and all work together to achieve a common goal. The data handling and attitude and orbit control systems utilize embedded software extensively. The ground systems for satellite tracking and payload data processing involve computing and communication systems with tracking antenna. The satellite design, fabrication and testing need multiple field expertise. Satellite projects provide practical experience for students of many disciplines. As the student satellites are launched as piggyback to main operational satellites, the challenge in fabrication of student satellites lies in making satellites with less mass and small in size. Due to this, student satellites are in mini, cube, pico, nano, and micro satellites categories with payloads catering to specific applications. These satellites were designed, fabricated, and assembled at corresponding institutions using their funds. ISRO supported in test activities by providing access to its test facilities at UR-RAO Satellite Center because the test facilities like thermo-vacuum chamber and vibration table are costly. Free launch support was also provided by Polar Satellite Launch Vehicle, PSLV. The Fig-1 provides different subsystems in the satellites and Table 1 provides the names of Indian student satellites and institutions. 2. Launched satellites. 1. Anusat. Anna University Satellite, Anusat, is the first satellite designed, fabricated, and tested by Indian students too. It was a cooperative mission of Anna University, Chennai, and Indian Space Research Organisation, ISRO, 3. This satellite was designed and fabricated at Madras Institute of Technology, MIT, campus of Anna University. Most of the subsystems in this satellite are made up of commercial off-the-shelf, COTS, components. The Fig.2 shows the satellite and the Table 2 provides the salient features of the Anusat. Fig.2 Anusat. Objective. To encourage the involvement of the Anna University faculty, researchers, and students in space technologies to work as a team. To gain hands-on experience in microsatellite development. Payload. The Anusat payload was designed to relay the data collected from one place to another place. The payload was designed and fabricated by the Anna University. Ground station. Independent ground station was set up in MIT campus of Anna University and houses the telecommand, transmitter, and telemetry receiver systems. The telemetry receiver sensitivity is -110 dBm. 2. Studsat. Studsat was the second student satellite of India fabricated by a consortium of colleges from Bangalore and Hyderabad. The consortium was led by Nyusat Meenakshi Institute of Technology, NMIT, Bangalore. Other colleges contributed by designing and fabricating different subsystems for. The list of colleges involved in this project is as follows. Bangalore. Nyusat Meenakshi Institute of Technology, NMIT, MS Ramaiah Institute of Technology, Misrat. Rashtriya Vidyalaya College of Engineering. BMS Institute of Technology, Bhimsat. Hyderabad. Chaitanya Bharati Institute of Technology CBIT. Institute of Aeronautical Engineering, IARE. Venice Institute of Technology and Science, VITS. The Fig.3 shows the Studsat-1 and the Table 3 provides the salient features of the Studsat. Studsat_autoed. Fig.3 image of the Studsat-1 CubeSat. Objective. To promote space technology in educational institutions. To encourage research and development in the design of a miniaturized satellite along with all the experiences, enthusiasm, and efforts necessary to bring such a project to completion. Payload. The Studsat payload is a CMOS detector-based camera designed to get 90 spatial resolution. Ground station. An independent ground station called NASTRAC was set up in Nyusat Meenakshi Institute of Technology. It received the telemetry data and confirmed the satellite is in mission mode. 3. Jugnu. Jugnu is a nano-satellite designed and fabricated by students of Indian Institute of Technology, IIT, Kanpur 5. It is a 3U CubeSat aimed to image the Earth for agriculture and disaster monitoring purpose. The Fig.4 and Table 4 provides the view and salient features of the Studsat. Objective. To get students involved in research activities based on affordable MEMS technologies. To test new solutions for the future cost-effective space missions. To set the path for future upgradations and study such validation of concepts. Payload. The Jugnut payload is a near-infrared, NIR, camera with 640 x 480 pixel area array detector operating in 700 to 850 nanometers spectral range. It has an f/4 optical system with 35 mm focal length. The acquired data can be stored in 2 GB triple modular redundant memory. Ground station. A ground station for monitoring and control has been established in IIT Kanpur. It consists of Yagi UDA antenna for uplink and downlink, GUI interface in LabVIEW and rotary system. 4. SREAMSAT. SREAMSAT was designed and developed by the students of Sri Ramasamy Memorial, SRM, University, Kattankulathure, Kanchepuram district. The view and salient features of the satellite are provided in Fig-5 and Table 5 respectively. Objective. To monitor greenhouse gases in near-infrared region 900 nanometers, 1700 nanometers. Payload. SREAMSAT payload is a grating spectrometer for monitoring Earth-based sources and sinks of anthropogenic and natural sources of greenhouse gases. Ground station. The SREAMSAT team set up a ground station at the SRM University Kattankulathure campus and tracked the satellite. 5. Svayam. Svayam, a passive stabilization communication satellite was developed by undergraduate students of College of Engineering, Pune. The payload flown on this satellite is to support point-to-point communication. 6. User can send and receive messages from one point to other point on the Earth. The view and salient features of the satellite are provided in Fig.6 and Table 6 respectively. Objective. To demonstrate passive attitude control. To provide point-to-point messaging services to the ham community using a bidirectional communication satellite. UHF channel performance evaluation. Develop a bidirectional communication satellite. Payload. The payload was designed to support message store and forward. 6. Satyabhama. The Satyabhama satellite was designed and fabricated by students of Satyabhama University, Chennai to measure the concentration of greenhouse effect gases. 7. The satellite is shown in Fig.7 and the salient feature of the satellite are provided in Table 7. Satyabhama satellite.jpg. Fig 7 Satyabhama Sat. Objective. To maximize the learning experience of the students. To provide a real-time design and development experience for the students on compact space systems. To monitor the concentration of greenhouse gases present in the atmosphere. To obtain the pollution model for India through the data collected using spectrometer payload. To interpret the acquired data and represent the concentration of greenhouse gases in ppm. Payload. It is an imaging camera, Argus 1000, operated in infrared spectral region. The payload is operated only over the regions where the experimentations are interested, and it delivers the data to the onboard computer, OBC, for transmission, when it crosses the radio window of ground station, which is being built in Satyabhama University campus, Chennai, India. Ground station. Ground station is established in Satyabhama University, Chennai. 7. PISAT. PISAT was designed and fabricated by a consortium of Indian colleges led by Peace University, with the support of ISRO, Indian Space Research Organisation, and IE, Institution of Engineers, of India to provide a hands-on environment for students in all aspects of satellite building and operations. 8. Fig 8 PISAT. Objective. To develop, design a space system in university environment with our students and young faculty. Payload. The PISAT payload is a 166 GMC MOS-based camera with 10-bit radiometric resolution. It has an area array detector with 2048 hx 1536 V pixels. This covers 185 kilometers x 135 kilometers area with 90 m spatial resolution. Objective: to enable students and faculty to gain knowledge and experience in the field of satellite and space technology. To empower the satellite team with the skills to develop the satellite through various phases of design, analysis, fabrication, and testing until the flight model is made. To launch the satellite into orbit and measuring total electron count of the ionosphere. To involve students from other universities in our satellite mission by building ground stations in their universities. Payload. The Pratham payload is designed to derive the total electron count in the ionosphere. Ground station. Separate ground station is established at rooftop of Aerospace Department. In IIT Mumbai. Atharva College of Engineering also established a ground station for Pratham. One ground station was set up in France by French students to receive data from Pratham. 9. Nyusat. This satellite was designed and fabricated by Nurul Islam University, Tukkalai, Kumarakoil, Tamil Nadu 11. Objective: to enable new entrants in the industry / next generation students and aerospace aspirants. Payload. The Nyusat payload is a 4-spectral band wide field sensor. It covers 50 x 50 km and 25 m resolution from the altitude of 500 km. Ground station. The Nyusat ground station consists of Mission Control Center and Payload Data Processing Center. It has a 3-meter antenna which supports UHF downlink and VHF uplink. 10. Callum Sat V2. The Callum Sat V2, payload named after former Indian President APJ Abdul Kalam, is the first to use the 4th stage of PSLV as an orbital platform. January 24, 2019. This payload was developed by students and Chennai-based Space Kids India. The satellite is the smallest, weighing 1.2 kilograms and has a lifespan of 2 months. 3. Satellites under development, MAU with ISRO. 1. Parikshat. Parikshat is being developed by Manipal Institute of Technology, Manipal, Karnataka. MAU is signed with ISRO for the launch of the satellite 12. 2. ITMSAT. ITMSAT is being developed by students of Indian Institute of Technology, IIT, Madras 13-16. Objective. The objective is to study the precipitation of high-energy electrons and protons from Van Allen radiation belts to lower altitude of 600 to 900 km due to resonance interaction with low-frequency M waves. Payload. ITMSAT will carry space-based proton-electron energy detector, SPEED, instrument as payload to measure proton and electron fluxes in the Earth's magnetosphere. 4. Continuation satellites projects. Some educational institutions are proposing to launch satellites. Satellites and the institutions are listed in Table 11. 1. Studsat-2. The Studsat-2 project is proposed with 2 nanosatellites to prove the capability of nanosatellites in docking experiment in space 17-18. 2. PISAT-2. PISAT-2 is proposed with imager which may point towards space for the study on stars. 3. SREAMSAT-2. SREAMSAT-2 is proposed to reach Moon and have a study in the Moon's surface 19. Satellites launched by other agencies. 1. Callum Sat. The Callum Sat, named after former Indian President Abdul Kalam, weighing 64 grams, was designed and developed by 18-year-old Tamil Nadu student and his team. This satellite is 3.8 centimeters cube with 3D printed reinforced carbon fiber structure. The instrument carried by the satellite was Geiger-Muller counter. This satellite was launched by NASA's sounding rocket in June 2017. Suborbital space flights technically enter space, but do not get into orbit. 6. Institutions involved in space studies. Many Indian institutes of technologies have involved in space-related studies through their various departments. Indian Institute of Space Science and Technology, IIST, which is under Indian Space Research Organisation, is carrying out many space-related research in collaboration with other universities in India and abroad. Mainly it focuses in developing new technologies required for future satellites and launch vehicles. 1. Satellites launched with balloons. Many colleges have started the satellite system study and testing their systems by launching them using balloons. Some colleges are mentioned below as samples. 2. Peri-Armenian Institute of Science Technology, deemed to be university. A team of girls of Peri-Armenian Institute of Science Technology, deemed to be university, Volum, launched a satellite using helium-filled balloon. The satellite was capable of sending live telemetry consisting of data and flight parameters to the control station at missed premises. 3. Vellore Institute of Technology, VIT. 12 payloads with satellite bus were launched using a helium-filled balloon by school students during the National Space Challenge 2020, NNSC, from Vellore Institute of Technology, VIT. The balloon was expected to reach an altitude of 20 kilometers. 7. Conclusion. The Indian Space Research Organisation, ISRO, has created space systems awareness among Indian students and helped in design, fabrication, testing, and launch of satellites developed by Indian students. Now many colleges continuing the space study autonomously. Acknowledgement. The author wished to acknowledge the Director U.R. Rao Satellite Center, Bangalore, and the Program Director, IRS and SSS Program for their continuous support and encouragement.